Welcome to another episode of the .NET Show. Now, one of the technologies that people have been talking an awful lot about is peer-to-peer applications. As it just so happens, there's a group here at Microsoft that's been developing a little application to help expose the .NET framework to developers, and they happen to choose to use peer-to-peer technology in order to add the infrastructure to this application. So what I'm going to do is I'm going to take and spend today's episode talking to them about not only peer-to-peer applications, but also the application they developed. It's called Terrarium. If you came to the PDC, you might have seen a preview of Terrarium, what it is, and actually got a chance to use it a little bit. So we'll give some more information about Terrarium, talk about peer-to-peer applications, and maybe give you some links of where you can actually download Terrarium as soon as they get it released to the public. But first, let's check in with Erica and the news.
Hello, I'm Erika Wiechers. Welcome to the MSDN News Update. On December 13th, the ECMA General Assembly ratified the C# and Common Language Infrastructure specifications into international standards. The ECMA standards will be known as ECMA 334 for C# and ECMA 335 for the CLI. There is also a technical report on the CLI, which will be known as ECMA TR84. In addition, ECMA approved the fast-track motion of these specifications to the International Standards Organization. On January 7th, in his keynote address at the 2002 International Consumer Electronics Show in Las Vegas, Bill Gates announced the launch of Windows CE.net. Windows CE.net is the next-generation embedded platform for building small-footprint smart devices such as handhelds, smartphones, set-top boxes, retail point-of-sale devices, and displays. To help developers get started quickly building their Windows CE.net based devices, Microsoft announced new promotional pricing of $995 for the Windows CE.net tools, free availability of evaluation and emulation editions of the tools and platform, and source access to additional Windows CE.net components. Also in his keynote, Bill Gates previewed an early set of technologies for Microsoft's new Windows eHome division, codenamed Freestyle. Freestyle provides a simple user interface accessing music, videos, TV, and photos from anywhere in the room using a remote control. Users can also watch, pause, and record live TV and easily search for shows using a built-in electronic programming guide. Building on Microsoft's .NET framework, Windows Media Technologies, and Universal Plug and Play, the Windows eHome platform will enable developers to author managed applications and services that can be distributed across network PCs, AV components, and other devices in the home. Hardware designers are encouraged to learn more at April's Windows Hardware Engineering Conference in Seattle. For more information, visit www.microsoft.com/ehome and watch for eHome information releases, including early development kits during the first half of this year. In January, Microsoft released the Office XP Web Services Toolkit. This toolkit brings the power of web services to Office XP solutions by enabling developers to use the UDDI registry, a .NET web service, to discover web services and then integrate a web service into Office XP solutions directly from within the Visual Basic for Applications editor. In addition, the toolkit includes a set of white papers and samples that illustrate consuming web services within Office solutions. And that's been the MSDN News Update. I'm Erika Wiechers.
Welcome back. And like I mentioned, today we're going to talk about peer-to-peer computing and how this works within a .NET environment. Here to join with me on this, I have Lance Olson and Erik Olson. Now, in the last couple episodes, I had two Jims on last episode and a bunch of Marks on the episode before that, and now I got two Olsons. I assume there's no coincidence here. You're both last names Olsons?
No, we're brothers.
Okay. And which one joined Microsoft first?
Lance did, actually.
And he kind of brought you along, or
he kind of brought me along. Yeah.
Okay. Which one's the older brother, younger brother?
I'm the elder. Lance is the wiser, and so I followed him.
Yeah. Don't buy it.
Now, I brought you on because you've actually got an application you guys have helped design called Terrarium that we're going to talk about a little bit later that is doing some peer-to-peer explorations with .NET and stuff like that. Mm-hmm. Before we dive into Terrarium and some of the .NET capabilities, I'd like to spend a little bit of time just discussing peer-to-peer computing. by itself. And what exactly is a peer-to-peer application framework?
So I look at peer-to-peer computing as really the opportunity that we have to use multiple resources around the network and leverage those resources to accomplish a task. It might be building a more collaborative application, or it might be using unused resources such as CPU or disk space on one of the machines or a group of the machines across the network. But it's really just building different functionality into the application that can leverage the resources better and leverage the nodes that are running on the network better to make more compelling applications.
So like, right now the traditional web server sort of model that people are familiar with is not a peer-to-peer model because it's a client application, the browser or something like that, talking to a server someplace. And so you're talking about having this peer-to-peer model. It's actually two different clients. So it's my computer in my house talking to your computer in your house without having to talk to Microsoft.com or AltaVista.com or something like that in between us.
Right. That's correct. And I actually think that the applications that are going to be, the applications that we've seen that are the most compelling aren't the ones that necessarily only talk to a peer, but it's more like you take the client-server scenario and the client-server model, and then you apply peers to it. So it could be an application that it may be talking to a central server for some things, but then it may also have the ability to branch out and talk to other peers for additional functionality.
And the key benefit you're saying is just to distribute the processing load out to the edges of the network?
Yeah, well, there are different kinds of scenarios. The scenarios where you're looking at reusing resources, the benefits really are just the fact that you've got other CPU power or other disk space that's available among the other peers that you can leverage. There are also the collaboration scenarios where it's really more, you might want to talk to a central server to figure out which peers you can talk to, and then after that point you may want to talk directly with those peers, and an application may not, there may be barriers that would occur if it were trying to go through a central server that wouldn't be there if you could just talk directly to the other peer.
Another useful model that kind of builds on that is the fallback model. I want a resource, I'd like to get it from the server, but maybe the server's inaccessible or networkologically I can't get to it for some reason. Some peer next to me has the same resource and I might be able to get the same resource from them. And so it's similar to the same approach, but kind of another way to look at it.
Yeah.
I guess one way that when you're talking about going through the server to locate a peer you want to deal with and just drop back and talk straight to the peer, that reminds me of like, the standard gaming environment where you want to do like a network game sort of thing. With these Twitch level games, so we really need as high throughput as possible, you wouldn't be wanting to take and have to transmit my information to the server, from the server out to the other client.
Right.
I'd want to talk straight to that client, but to locate all the other people willing to play, I'd want to have like this standard lobby on a server someplace we're all coming to. So we gather at that lobby, so we're gathering at the server, and then we distribute our loads out to the client applications.
Yeah.
Now, it wasn't that long ago that people were talking about peer-to-peer computing being the next big thing in computers and stuff like that. And recently now, articles been coming out saying, okay, the peer-to-peer bubble has burst, and peer-to-peer applications probably aren't the next best thing. Do you think that there is a future for peer-to-peer computing, and if so, what do you think that future is going to look like?
I think that, yeah, that's a good question. I think that the peer-to-peer bubble was, the peer-to-peer hype was sold as a new application model and an entirely new world around which we would build applications. And I think that the truth of the matter is that it's much more evolutionary and that you can integrate peer functionality in. And so I think that the answer is no. Peer-to-peer is certainly not dead. However, the hype and the notion of peer-to-peer as just a standalone concept is probably something that is better off evolved or sown as more of an evolutionary step than something that's just an entirely new model. And so the peer-to-peer world, as I see it in the future, is more one of applications that are more fault tolerant or are more able to interact and more interactive and have a better ability to contact other resources that are available on the network. So they're just like the applications today, only better in those senses.
So what would be like an example scenario you might think might come out in the future of using peer-to-peer computing where someone says, wow, I'm really glad that this sort of framework exists because I'm able to get to my resources better?
One that I run into quite a bit that really disturbs me today is I have 3 machines in my office, and each day or maybe once a week I go in and I get the latest build of the product that I'm working on in my team, and that build might be over 100 megabytes of data. And I go to the first machine and I go out to the network, to the central server that's got the build on it, and I start installing that build, and it takes a little while to come down and set up my machine. And then when I'm done with that, I go to the next one and I do the same thing. And then when I'm done with that, I go to the third, I do the same thing. And I have to wait. I do it in the morning because that's when the network is least busy. And I would really like to be able to just do it once and then have that information, because I've already got a peer right there in my office on the fast network, the local hub. I'd like the other peers to just go right off that first one and get the data that's already been downloaded, as an example.
So the issue you're facing with, you've got a central server that this installs off of, and everybody on your team, as well as other teams inside of Microsoft that are trying to load this latest build, and they're needing to do it the next 12 hours, they're loading it off that same server, and so that server's just getting overloaded. And so you're talking about actually distributing the load out. And I suppose the next concept is as each person loads it out, maybe they can take and announce themselves as holding the latest bits, and that way when you ask for it, you're just automatically getting it from someone else rather than always going to the central server. Mm-hmm. Okay. What are some examples of applications, if I was like out at Boeing or something like that and developing some apps that I might think, gee, a peer-to-peer model would really help me really well in writing this application, or something I need to think about for developing this?
The most common one that I've seen has been in a scenario like that is distributed processing. So they may want to take, let's say I'm building an airplane and I have a lot of data that I need to process and render in a real-time fashion. Peer-to-peer applications could be written that use the different resources on the network, use the other PCs on that local LAN to process a little chunk of the airplane diagram, and maybe use some of their memory, and then just have one machine that is the machine that's actually the application that's then rendering all that data that gets processed. There's a trade-off there, obviously, between how much data you shove down the network and you move back and forth on the network versus the value you get from pushing it down the network to other peers. And so they work with that trade-off. But applications that do a good job of that can really provide a much better experience for the person who's using the application that's doing the rendering. Mm-hmm.
Now there you're actually talking about running code in a peer-to-peer model, where previously we were more like talking of transferring data peer-to-peer. Yeah. Doesn't that get a little bit on the scary side? I mean, if I'm going to take and be pushing code down to your machine and having that run on your machine, is that something you're going to want me to do?
Yeah, I think that historically it's something that was on the scary side, but that's one of the key problems that we've gone after with the .NET framework. And one of the things that we've got some code that I'd like to show, and some other things we can talk about today. I don't know if Erik's got other stuff to add to that. It's kind of an area that he specializes in too.
Yeah, mobile code has always been very interesting. We have mobile code running inside of the browser. It makes presentations more interesting, makes it easier to interact with web pages and various sorts of things like that. We have downloadable ActiveX controls and Java applets, and so mobile code is something that's really caught on. It is kind of scary to take code from an unknown source and run it. You don't know what it's going to do. Oftentimes it runs in your security context with the same set of privileges that you might have on your machine, and you don't know what that code might be able to do. So the common language runtime and the .NET frameworks have a facility, a security facility, where basically you can treat code with a partial amount of trust, or we call it semi-trusted or partially trusted code. And you can say, I want this code to be able to do interesting things, but not to be able to do unsafe things. And as an application writer or as an administrator, you have a great deal of control over exactly what those permissions are and what those sorts of applications can do. And so it makes for a very compelling environment in which you can actually share code with people. They can send you code, you can run it in a way in which you know it's effectively constrained in order to do the things it needs to do, but not to do anything untoward on your machine that might.
So can I tell it not to do animated GIFs and stuff like that on the screen? Or?
we do have a UI permission that lets you control whether or not it can display things on the screen, yes.
So now, then that's something that the application developer needs to interact with, or is that something the user interacts with?
It can kind of go both ways. So basically there's this policy system inside of the common language runtime that lets you basically define security policies. So when code originates from some point, whether it's my local machine or the intranet or the internet or various other gradations, then treat it in this way. And so as an administrator, I can say, I choose to trust a site so that it gets more control. If I'm an application author and I'm trying to load code into my application that was written by other people, I can apply constraints in slightly different ways to say, when I load code, treat it this way that came from me and treat it this other way that came from someone else. Typically, a user, the design goal of the security system is really that users don't have to interact with it. We hope that administrators will make policy decisions for their enterprise, and you might have a user that is running code on a machine that says, I really decided that even though Microsoft.com is an internet site, I want it to be able to do more advanced things on my machine. Maybe there's some application functionality it really needs. But the security model is aimed at not making end users have to make opt-in choices at the last minute. So no dialogues are going to pop up and say, do you want to run this, yes or no? We'll basically say, code comes from this area, the internet. Do you want it to run? And if so, here's the policy on your machine. And we ship with a very conservative, safe set of policy, and administrators can further tune it if they like.
So then it sounded like we had basically 3 different stopgaps in there. We have the user administrator, so a human being managing the system that is able to, but not necessarily required to, deal with the security settings. Then we have the application that might be running, dealing with security settings. And then we have the components that application might be loading. And so the application can specify what security the components can have, and the components can either choose to live in or outside of those security measures. Right?
Yes, that's true. Yeah, the application, we like to call that a host sometimes. It assumes that the application itself has enough trust to make policy decisions. If you're actually loading an application that you don't trust, it's not going to have the ability to make those decisions. But assuming that you want to run the app and it has some degree of trust, it can say, yes, I'm going to load components and I'm going to treat them in this way. Components basically can make some security decisions too. They can never gain more trust than the policy gives them. But they can say things like, if you don't give me the ability to read and write files or the ability to use the network, don't even bother to load me. I need that functionality. It's crucial to the component, and I opt out if I don't get that. And they can also do something which is refuse permissions that they don't want. And so if a component says, for example, I only need to draw animated GIFs on the screen, I never need to access the file system, please revoke the file permission from me. And so if someone loads my code and some malicious code ends up running and tries to co-opt my code paths to do something I don't want, it can't do it because I don't have the permission in the first place.
Oh, I see. So in that case, maybe the host application, for example, could take and tune down his own permissions, which means any of the components he loaded could not get more permissions than what the host application originally had.
Yes, that's true.
Okay. How do you see that the .NET application development environment itself assists in developing peer-to-peer applications?
Well, I look at it as because peer-to-peer applications are really just like maybe a classic client or a classic server application with the twist that they might be able to interact with other resources. The way that you develop a peer-to-peer application using the framework is the same as how you would develop a classic, a server or a client application. Now, a couple of the differences, one of the biggest differences is the fact that we have this security system that Erik has just talked about, and that's one of the biggest value adds that the framework adds for all types of apps, and it's especially applicable in the peer-to-peer case. But there are other building blocks as well, such as the Windows Forms technology for developing a rich client, or the networking APIs for interacting between peers, or the web services for having maybe a central server that handles some of the tasks of the peer-to-peer system.
Mm-hmm. Some of the other things that are real niceties there is that it's very easy to take data in whatever live form, some set of object graphs, turn that into either binary or XML SOAP representation, shoot that over the wire and reconstitute it on the other side. And so there's a lot of support for easily communicating between applications with technologies like web services or remoting, where you don't have to go and write a whole lot of code and develop application protocols all the time.
Mm-hmm. Mm-hmm. So in the application you wrote, Terrarium, how exactly is that taking and dealing with a peer-to-peer model?
Well, the Terrarium is a game that runs as a screensaver, and whenever the game runs, it runs as a client application. It's a screensaver. However, it's able to become aware of all of the other instances of that screensaver running on the network. And so it then uses the other peers, it contacts them, and it's able to teleport or transport. We call it teleporting. We'll talk about it in a minute. It's able to transport code from one screensaver to another and execute it in that screensaver. In the case of Terrarium, it's an organism, because in the Terrarium you build assemblies, or you build code that represents the artificial intelligence for an animal. So I could build like a scorpion or something, and then I introduce that scorpion into the Terrarium on my machine, and as it contacts other peers, if it succeeds, and if I've done a good job with the artificial intelligence for that piece of code, it will then propagate and spread across the other organisms, the other terrariums that are running on the network.
With Terrarium, that really is the limiting factor. You have to make your organism thrive in the ecosystem, and that's the hard part. Seeing how far it propagates. It's making sure it's basically a smart organization and well adapted to deal with the game.
So you have two components. The screensaver itself is using the peer-to-peer technologies to be able to trade these code blobs back and forth. And then on the other hand, you also have the code blobs that developers, like my audience, can take and actually write these code blobs that themselves aren't really doing any peer-to-peer coding, but they're needing to interact in a peer-to-peer environment so that they can take and be distributed to other systems.
That's right.
That's right. Okay. Now, you mentioned that the Terrarium screensaver application contacts the other systems. Are you using a central server to pivot on for that, or are you contacting each other in a peer-to-peer model instead?
We actually, when we first started, this is kind of it's been one of those lessons of when you do peer-to-peer versus when you do a client-server application. And when we initially started with the Terrarium, we said we want it to be all peer-to-peer. And so what we did was we used a broadcasting mechanism for each peer. So each peer would, when it came up, it would start announcing across the network with network broadcasts, hey, I'm here, are there any other peers here? And we found that we either had to dial that up very loud so that it could broadcast across the network through network boundaries like routers and hubs and stuff.
I'm sure our IT department just loved that.
IT really loved that. Right, or we had to tune it down, and if we tuned it down, then we would find that peers couldn't discover each other.
And little islands where people happen to be networkologically distinct.
Right, so what we ended up doing was moving to a hybrid model where we have a central server that you go to for discovery. So when each peer comes up, it calls a web service that it registers with and says, okay, I'm now running, and it creates like a lease with that web service and says, I'm now part of the system, I'm active, I can share with others. And then it asks also for the central server to tell it what other peers it can talk to, and it will then use that information to talk directly to those peers from there on.
So it's, at a certain level, it's almost like UDDI, where you've got a central UDDI server, and you take and go to the UDDI server to find the address of a web service you want access to. Once you've got that web service, you don't need to go to UDDI anymore, you can just go straight to the web service.
That's right.
Or that's still a client-server model. This is a client-client model doing the same level of functionality. So what sort of throughput do you see yourself getting from this network layer? I mean, what is the delay time of coming online, getting to the server, access, registering yourself, getting access to all the clients out there, and then starting propagating your code around?
We built in a number of dials that let us turn that up or down based on the bandwidth constraints that we have. I think by default it takes around 5 or 10 minutes to actually, it registers right when it comes in, and then it takes time for the address that it's registered to propagate out through the network, and that might take 5 or 10 minutes before you start seeing organisms floating in off other machines. Now that number really is dependent on the number of peers that you have available, and that's kind of a key point for peer-to-peer is that often if you have an application that is relying on peers for part of the functionality, you need to consider whether or not what the critical mass number is going to be for that application before it becomes interesting. If when we first started, it was just 5 to 10 of us that were actually running it, and so we didn't see a lot of the patterns in the network that we saw as it bumped up and went into the thousands.
And you're getting numbers into the thousands now here on the campus version of it.
Yeah, it's between 1 and 2,000.
And now, are you going to make this available on the internet itself at some point in time?
Yeah, at some point we will want to make it available for developers. We had it at the last Professional Developers Conference, and let developers kind of get a taste for it. And we'd like to get it out to the point that we give it to them and they can run it and even maybe create their own servers and use it as a, not only something to have fun with, but also something to cut their teeth on .NET with and get used to the code and play around with.
Mm-hmm. Now, what were your original objectives in developing Terrarium?
Originally, we wanted to come up with something that was fun and was appealing to people, so that people would, the developers would be able to do something that they enjoyed and that was compelling for them to actually download. And we also wanted something that let people see some of the powerful principles behind .NET and behind the .NET framework and the Common Language Runtime. So we wanted to highlight the security mechanisms and how we could send mobile code around and host that code. And then we also wanted to use it to be something that could highlight the various components within the framework. Mm-hmm. So it spans across nearly all of the technologies in the framework.
It really does. It uses the network. We have an ASP.NET server. We have web services. We have COM interop. We have threading. It's security. It's basically got most of the pieces of the platform built into it one way or another. So it's actually turned out to be a very good stress test for the platform. We've used it when a game has to obviously keep up a certain frame rate or it's not very interesting and visually compelling, and so it does a lot of GC collections, it creates a lot of data, it does a lot of network activity and those sorts of things, and it's been useful for us as a kind of a development vehicle or a way to make sure that the frameworks are doing what we think they are as well.
Yeah, I've always felt that the best way to stress test a language, a compiler, an operating system, or any sort of platform technology is to write a cool game out of it, because with a game you always see something you can improve, whether it's the video frame rate or whether the interactivity or something else like that, and so that's why everyone should be writing games all the time.
Yeah,
that's right.
Yeah.
Test these things out. So the peer-to-peer aspect of it wasn't originally a goal that you're trying to deal with; it just became the way you chose to solve the problem.
We wanted to make the application as compelling as possible, as fun as possible, and one of the things that we thought would make it fun would be this ability to actually have, everyone's seen a screensaver where you've got bugs or fish or whatever it is swimming around on your machine. We thought, wouldn't it be cool if, that fish could just keep swimming and swim onto somebody else's machine, and I could introduce my own organism in or my own creature, and it could crawl over onto someone else's, and so peer-to-peer just seemed like a logical fit.
Mm-hmm. Now, is this something that my audience at some point in time will be able to load onto their systems and kick the tires? I mean, we're spending so much time talking about Terrarium. I'm sure they're all saying, hey, I want to take a look at this. I want to actually do some stuff with it. What are the plans for making it available time-wise?
It is something that around the same, we're currently targeting the same time as the VS launch and the VS Live, upcoming VS Live.
That's middle of February.
Middle of February. It is something that it's actually not our job, so it's something that the joke is that most of it was coded between the hours of 11 o'clock at night and 2 in the morning when we were done doing the work that was actually part of the .NET framework. So that ship date is dependent on our ability to have time between 11 and 2 in the morning. But we're currently pretty solid on hitting that date.
Okay, so it's probably a pretty good chance that sometime during the month that this episode is on the web that it'll be available. And when it does become available, I'll make sure I put a link to it on this episode. And if by chance it ends up slipping after this episode's not on, I'll make sure I put a link in the next episode or in the transcripts or something like that, so people can always have access to it. Because I've seen it, and I'm running on one of my systems, and I think it's kind of a fun little application. I've messed around a little teeny bit with writing some of my own animals, but I haven't actually released them out there yet because my code wasn't quite good enough to beat some of the guys out there. So those guys are pretty good.
Yeah, they are.
Yeah. Now I guess conceptually, just to understand that the application itself, I always compare it to the SETI at Home program, which is also a screensaver that is running code in your system. The main difference is that rather than simply taking the code from the SETI at Home people, you're actually allowing the person that is on the machine themselves to interact by adding their own code modules to it as well.
Yeah, and I'm not sure with SETI at Home. I believe it's the work that each client is doing is scheduled by the server. Mm-hmm. And in this case, in addition to the Terrarium uses the server for discovery, but it actually then can talk directly to the peer, so they do interact directly as well.
Right.
Basically, the physics of the world are built into the system itself, but beyond that, what kinds of animals you have on your system, what kinds of plants, and how they interact is all going to be completely distinct on every peer.
Okay, so then that's using the peer-to-peer model to actually just propagate all that code around to other systems.
Yeah, that's right.
So just kind of in closing, what do you think are some of the key aspects for some of our audience who maybe not be doing anything with peer-to-peer at the moment to be thinking about of why they might want to think about writing peer-to-peer applications and what sort of resources they might need to go to look up to make sure they're writing applications properly?
Well, I think that from the perspective of why would I want to use a peer-to-peer application, or why would I want to introduce peer-to-peer concepts into my application, I would think of it depends on the scenario. I would be thinking of things like, do you want more fault tolerance? Well, in a lot of cases, we do want more fault tolerance in applications, and can we achieve that by having multiple redundant servers that are acting as a peer kind of a cluster? That's one case. Another one might be, am I doing something that's resource intensive? Am I doing something that requires a lot of memory or a lot of CPU? And could I better serve my end user by leveraging other resources that are available on his or her network to make the application experience better? And so it's really focused on resources and the utilization of the scenario.
Now, that's a couple times you brought up now the fault tolerance in respect to peer-to-peer. Now, I can understand the resources and sharing that standpoint, but exactly how does a fault tolerance come into play with a peer-to-peer model?
Well, if you think of like a traditional client-server case, where a client has a known URL that they're requesting a resource from, and if that server is too busy or they're not able to contact that server, it's down for some reason, or maybe some infrastructure in between the client and the server is down, they're out of luck. In a peer-to-peer system, you may have multiple peers that you can go to for a particular resource, especially if you've got like replication built in so that they're actually copying, maintaining some state on each of the peers. So if I had like a document I needed, or some other piece of information that my application needed, I might try what I know as the central server. Maybe it's just the main peer that I contact. But if that fails, I may have other peers that I can then go talk to. And from the user's standpoint, the experience is the same. The user doesn't say, oh, the network's down, or oh, the server's down, I can't get to it. They just go, oh, it took a little longer, tried another peer, and it got the result back.
So it'd be similar to like disk mirroring in a standard server environment sort of thing, where you're actually taking and making shadow copies of information that you're writing on. If one drive goes bad, you just go to the shadow copy.
I think it has a lot of parallels with replication and things like that.
Yeah.
And so it's more like preparing a fallback scenario, which means also that your application have to have some intelligence to maintain a directory of the alternate nodes, or some way of doing a broadcast of saying, okay, I'm needing this information, who else has it out there?
That's right.
Okay. So any other closing remarks about, from an architectural standpoint, what peer-to-peer applications should be doing and thinking about?
I think another thing is to take a hard look at the CLR's security system. It's certainly not the case that every application will want to host mobile code, but those that do should take a hard look at the things that we have to offer there. In addition to that, a lot of peer-to-peer apps are interested in doing things like collaborative work groups. Here's a work group, and I'm going to propagate data that only people in my work group can read or interact with. We have a lot of strong cryptographic support in the framework class libraries that makes it very easy for developers to do that using standard security protocols and cryptographic protocols. And that's another interesting thing. And then I think a lot of the network support is very easily accessible in the .NET frameworks as well. And so if you're building a peer-to-peer application that needs to do things on the network, you should take a hard look at some of the networking things that we have in there, and it makes it really easy to do things like asynchronous network calls, or calling a central server with a web service is trivial and requires almost no developer coding. So those sorts of things make it very easy to build applications that play together well on the network, and peer-to-peer developers should take a hard look at those.
Okay, and all those are things, we actually have some sample code that we're going to show people in the second segment.
That's right, conveniently enough.
So I think probably just a good time to take a brief break, and when we come back, we'll take a look at some of that code and show people how to deal with the security model and cryptography, as well as accessing the .NET application through a network sort of capabilities.
Okay, great.
So after this brief break, we'll come back, we'll take a look at some code to show you how a peer-to-peer application can be used, as well as to add some security and cryptography and network application connectivity to your applications. Now, in just a few minutes, we'll be back to talk to you about actual programming of COM+ and what that actually looks like in code. So be with us soon. That didn't work. That terrible.
Like say, I lost my train of thought there, sorry.
But they don't want to be a wholesaler, and they don't want to have
That's not good.
Yeah, we gotta work on Mark. He's looking a little peaky.
it speeds up the, I don't know what I'm trying to say here.
And third-party language developers, we have one big environment for them. I'm sorry. I thought somebody was laughing when I was talking.
And I understand that when I send you the email that request is not going to be, probably not going to be processed in your case for several months. We got to cut that part out.
Well, Bill, I'd like to thank you for spending this time with me, and I learned an awful lot about the convention center and about wine.
Center. No more wine for you.
Be sure to stay tuned to future episodes of the MSDN Show, where we'll drill down even further into the technologies.
We hope you enjoyed this episode of the MSDN Show talking about the .NET framework.
Oh, run. Not enough time. Okay.
Well, that's the end of another MSDN episode. That didn't work. Okay, so what I'll do is I'll take and turn to my thanks, Frank, for joining us. So I'll skip the first part of my closing bit. Turn to the thanks, Frank, for joining us, and thank you for joining us. That's the end of this complex episode. Okay. Thanks, Frank, for joining us, and thanks, audience, for listening to what we had to say. And that's the end of today's show.
Sorry, I screwed you up there.
You did. I saw those lights flashing. Gee, we've still got some more wine left, so I think we'll just kind of sit here and drink it.
Finish it ourselves, shall we?
Yeah.
Prost, thank you.
Thanks
for coming. Boy, those make some noise, don't they?
Welcome back. Joining me again, I have Lance Olson and Erik Olson, and we're going to talk about the Terrarium application they developed to display peer-to-peer application functionality, as well as getting people interested in actually writing some .NET applications. Welcome back, Lance and Erik.
Hey.
Now, we spent a little bit of time in the last segment talking about this Terrarium application, so I thought it only fair to take and actually show the audience what Terrarium looks like and discuss, some of the concepts behind it and why you chose to use this for your testbed application for helping people understand the .NET framework. So why don't you go ahead and talk about it a bit?
Okay, so this is the Terrarium application, and we basically have an overview of kind of what looks like a world with organisms or bugs crawling around in it. In this case, they look like ants. And you also see some plants. And the way the Terrarium application works is the objective, we liken it unto baseball in the sense that there are about a million different ways that you can win. It could be statistics. It could be based on the organism that lives the longest, or the one that creates the most offspring, or the one that is able to take over the world and have the highest population. And so how it works is you have plants in the world, and the plants get their energy from ambient light. And they don't really do that much other than just kind of grow and then reproduce every so often. Then you have herbivores that eat the plants, and then carnivores that eat the herbivores. And they all kind of live in this cyclic world where any developer can introduce an organism of any type and put it into the world and try and have it survive.
And so like right now we're seeing here is the Terrarium application itself is providing the basic background that we see there, but all the creatures and all the plants as well are actually code components written by somebody else that's just kind of bouncing around this Terrarium world across the network from peer to peer.
Yeah. This particular instance of the Terrarium is running. It looks like if you look up at the peers section up at the top here, you can see that there are currently 435 other peers that are running in its what we call an ecosystem, its universe. And we have a little blue ball that kind of rolls around the world. There you can see it. It's called the teleporter. And what happens is each of these items that you see on the screen in that world, they are an assembly. They're I think of them as like a DLL or a class library, a piece of code that lives in and of itself. And whenever the teleporter rolls over them, it picks another peer on the network to send that organism to. And so it will teleport the peer. It will actually physically take the assembly and transport it across the network to that other peer. And if that other peer doesn't already have that assembly installed, it will install it. and then it will transport the state so that, for example, if it was an ant that was hungry, when it gets done teleporting, it'll be just as hungry. And it transports the state across, and then it creates an instance of it and applies the state, and you've basically got the same organism that you had on one peer now teleported over to the other peer.
So now your goal originally with this application was not so much in the peer-to-peer model, but just to get people interested in competing in this terrarium landscape by writing these components with the .NET framework and hosting them on their own system, and then in that fashion getting them teleported to other systems.
Yeah, that's right.
So the developers, the individual users out there who are using the system, developing the creatures, really themselves aren't using peer-to-peer, but you had to do some peer-to-peer code in order to make this application work properly in this environment.
Right. They're really more just, they're benefiting from the fact that we as the developer designed the application to use peer-to-peer technology, in the sense that it's a more exciting application for them because of that. You can get, you can imagine a bug, an organism crawling across your machine that just came from somebody's machine in Russia or some other part of the world, and it's kind of exciting for them to see these random organisms coming in and then fighting their organisms on their local screen.
Mm-hmm. It's kind of an interesting design point too, because an organism is really only concerned with its own survival. It knows how to walk around and eat and do whatever it is that it does. It can reproduce and pass DNA on to its offspring and those sorts of things. But it doesn't have to worry about, what's my security context and how do I send myself to some other peer on the network, or, all of the hard problems that the game infrastructure itself solves. And so developers are kind of free to worry about the things that they're interested in playing the game, focus on the application logic. And I guess the extension of the design pattern to applications is that if you design your peer-to-peer application in such a way as to kind of hide a lot of the details from developers, so they can focus on writing their object and put whatever logic it needs into it, and then maybe use some of the services that the framework provides, like serialization, to be able to transport the state easily without having to explicitly write lots and lots of code to deal with those sorts of problems.
Mm-hmm. Mm-hmm. Now, when I see this and discuss with you about the concept of moving code from client to client, it brings up again the whole security problem we mentioned in the first segment. Can we maybe dive into some code and show how this security stuff actually works in this environment?
Let's take a look at it. Yeah, what we've actually done here, the Terrarium has a little bit of code in it, and it was more than we thought we could look at feasibly. So we basically took the idea behind the Terrarium and developed a little standalone application, which we'll dive into here, that does exactly the same thing. So, as I said before, the runtime security engine, go ahead and flip over the source there, Lance. Okay. Let's go ahead to the code host. In fact, you want to start, why don't you walk us through what the app does, and then we can take a peek at the code if that seems reasonable.
So we were trying to come up with something that was kind of an encapsulated sample, a simple sample that did the kind of the essence of the code hosting that the Terrarium does, in a way that we could then share out and let developers get a hold of this code and see exactly how it works. So what we have here is a Windows Forms application, and that application has a button on it called Load Untrusted Code. And the application, it has full trust on the system when it runs, so it is able to do basically whatever it wants, or whatever I, as the user running the code, have access to do on the system. However, one thing that it does is it creates an application policy such that code that doesn't have that full trust, or doesn't have the right evidence associated with it, will only be able to do what it says that code can do. And so we have a button here called Load Untrusted Code, and what that button does is it loads up the code that it loads up a button that we will call the untrusted button, and that's kind of the host code. And if you think of the Terrarium, that's like the organism that just got teleported into your world. So for a peer-to-peer application, this is really, it's how you want to treat code that may have come in over the network or come in from another peer.
So it's not so much a criminal button, so it's not a button you know is bad, but it's something that you don't know. You don't know where it comes from, so you want to take and treat it in an untrusted standpoint.
That's right. First. And so we defined the things that we think are unilaterally safe. It doesn't matter who wrote the code, it can do this, and we're okay with that. And so basically there are different ways to get the same behavior. What we've chosen to do in this application is to define a security policy at the application domain level. And what that means is that our application starts up, there's policy on the machine that maybe says, here's the policy for my enterprise, here's the policy for this machine, and I might have user-specific policy. I'm not going to talk too much about that, but that gives your application itself a set of permissions. And then we define a policy that says, code signed by our application, so if it has a cryptographic signature that we developed, and for which we own the key, then go ahead and trust that code as much as the code on the machine is trusted. And then code that runs itself, code that's signed with the framework's key that's already part of the system, it also needs to be able to do what it needs to do. And so we're going to go ahead and trust that fully. And all other code, we're going to give some safe subset of permissions that we deem appropriate, and that's what these assemblies will get. It's also possible to do things like, say, load code from HTTP : somewhere, and then have it automatically get the permissions associated with that URL. And you don't need to write code to do that. It's also possible to just say load code and say, this code came from the internet. I don't care what the URL was. I'm telling you, the runtime security system, it's internet code, and it will treat it appropriately. So there are different ways to get the same behavior, some more complex than others. We kind of developed a way that we thought was appropriate for a lot of peer-to-peer applications, and that's what we're going to be showing here. We're doing it inside of one application domain, which means the application runs, we put the security policy there, and everybody runs in the same app domain. Another really common strategy for people that do this in their peer-to-peer applications will be to create multiple application domains, and they might have different security policy levels depending on how much you trust them or who they are. You know, if it's somebody in my immediate work group, they might run in a nearly full trust application domain. If it's somebody that comes from some other random pool of people, I might not let them run much at all. And the other advantage of doing it inside of other application domains is that's kind of the unit of code unloading in the common language runtime. So I load an assembly, it's in my application domain until the application domain itself is unloaded, and then all assemblies in that are freed. A little bit different than what developers might be used to today when working with Windows DLLs. So this sample, one application domain, one security policy, and Lance, let's go ahead and start looking at some of the code.
Okay.
Let's go.
Do you want to start with the button load or go to something else?
Let's go ahead and start with the main method where we instantiate the application and put the security policy on it, and we'll go look at the button load if that's okay.
Here's main.
So we've got main. The first thing that we're going to do is that we're calling a method in system.reflection from a class called appdomain, where we get the current appdomain, or the one that's running the code, and we're saying set appdomain policy. This is the way that we take a security policy and we assign it to whatever appdomain we're calling this method on. And we then go ahead and kick off our application and let it run. The key point here is that we're first creating the security policy, then we're letting things run. Let's go ahead and look at make policy level. This is a method that basically cooks up all of the security policy that we want for this appdomain that we're going to go ahead and use. We'll start here with the first couple lines where it says a first match code group. You can think of this policy thing as kind of like a tree or a graph of objects. And it consists of a couple of important pieces. In the runtime, there are things called code groups. And a code group says, when code looks like X, do Y to it. And we're going to say things like, when code looks like our code, on the basis of a signature, then give it some set of permissions. You might also envision saying things like when code comes from some site or some location on disk, then do these things to it. But the first statement here says it's a first match code group, which means that basically that we're going to give it a set of permissions associated with this group. And then we have what's called an all membership condition. So all code is the target for this particular code group. Every code gets, and then we're saying make execution only perm set. And this is a little bit of code which just gives code the right to run and not to do anything else. Basically, every resource in the frameworks is associated with a permission. So the file system's a resource, there's a file I/O permission. The network's a resource, there's a socket permission, and so on and so forth. We have some abstract permissions called the security permission that basically say the right to run, the right to create threads, and things like that. We're giving this code the right to run. And so as we evaluate the policy here inside of the runtime, we say all code gets the right to run, and then we'll move on to the next group. And this code basically is saying there's some functions that we're calling in there, one called make self-relative blob, which is looking at the code running this code, pulling the signature off of it, and creating a policy statement based on that. So this is just a fancy way of saying the code running in this host that we've signed, go ahead and get us the public key token there, and then we're going to give that some set of permissions. In this case, we're calling a method called make trusted perm set, and all that's going to do is create a permission set, and we can look at that code in just a second, which is fully trusted. It can do whatever machine policy lets us do, and then we'll say code with our signature gets that. We then have two more statements there that are very similar. They're saying code signed with the Microsoft Framework key and code signed with the ECMA standard key also get full trust. Those keys, of course, only the framework's key is only going to be used for code that's shipped as part of the framework, part of the platform. And then the ECMA key is used for things that are standardized in the ECMA standard, and again, are things that are part of the platform. We then create a policy level object. We go ahead and add our code groups here. Here's where we're building the graph. We've got our all code, and we're adding the child code groups, one for our signature, one for the Microsoft signature, for the ECMA signature. Then we go ahead and set that to the root code group, which is just basically a way of saying, let's create this thing, put it together. When this function returns, we set that thing on our app domain, and the security policy is in effect at that point.
Now were those dangling tabs I saw on the end of those lines important for the code?
Sorry?
When you had it highlighted, there were little extra tabs on the end of the lines.
No. Not important. Yes. So let's go ahead and look at make execution only perm set, and we'll just basically show what a permission object consists of. Okay, so the first thing we do here is we create a permission set object, and a permission set is just a bucket of things that you can do. Again, these permissions, individual permissions that relate to resources. In this case here, we're saying create a new instance of the security permission, and the side that's scrolled off there a little bit, if you want to scroll over, is going to pass in a flag, security permission flag.execution. So this is the right to run code. And again, we can choose to give this code whatever we want, and in a minute we'll come back and grant it slightly more privileges. Here we're saying you have the right to run, you don't have the right to access any resources other than that. We then basically add that permission to the permission set, and then we return it. And that is what we gave the code that was signed with, or gave all code, anything that fit into the all code membership condition here. And then the code right below that, make trusted perm set. This is basically, if you want to highlight that line right there, this is how you give a a piece of code full trust. We're saying permission state.unrestricted. So this is basically giving it an unrestricted policy, whatever the machine policy allows, and this is what we give to the code in our host and to the code assigned with the frameworks or the ECMA keys.
So that's when you really trust the code, this is what you give them.
That's
that gives
right.
access to anything that your application domain has access to.
And the Terrarium parallel here is Terrarium does almost the same thing. It trusts its own signature. It trusts, again, the frameworks code and the ECMA code, and then all code gets execution. So it looks almost exactly the same as this bit of code that we've got. Why don't we go ahead and run the demo?
Okay. You saw probably some commented out code in that last segment that we looked at, and that's because we're going to try loading a button that is a benign button, or benign in the sense that it only will do things that are allowed in the permission set that we currently have applied. And then we'll go ahead and uncomment some of those lines and get it to do something that violates the permission set, and we'll see how that behaves.
Okay.
So to start, when I say load untrusted code, this brings up a button that just moves around the form. I think it decrements the left position by a 10 until it gets to the edge, and then goes back into the middle of the form and keeps marching. It has a timer, and so it's basically just executing.
So in other words, this code had the capability of instantiating a button, creating a button, sticking it on the form, moving that button, and interacting with the form in that fashion.
It's actually important, the way we've written this code is that the host itself is the one that instantiates the button and materializes it on the form. The untrusted button actually wouldn't have had that right. Once we materialize it in trusted code, then it has the right to move its position around as long as it stays within the bounds of its parent and within the visible screen itself. So really all it's doing is moving itself around. If it tried to access its parent or go beyond its bounds or do something, you would see a security exception. So let's actually go ahead and change the code in untrusted button to try to read a file. Is that what we're doing?
Okay. So here's our button.
So this is the code you were loading up.
This is the code we're loading.
That we were loading in that button. And you can see I did it just checks to see if it's greater than, if the left position of the button is greater than 20, then decrement it by 10 and keep going, and otherwise jump out to the middle of the form by setting it to 250.
Not real fancy graphics.
Yeah, not real fancy. It's not quite as complex as those organisms crawling around the world. Let's go ahead and uncomment this line. So what this will do is try and read the boot ini file on C:\/ of this machine. So now
Which is something you probably aren't wanting something to do.
Yeah. The button is just moving around. We probably don't want it talking to the boot ini file, loading that up.
So what we've said right now is that it gets the right to execute, not anything else. We're going to run this code. We expect.
So I had to copy the DLO over that we were loading. load untrusted code.
And if you can actually read that exception dialog on screen there, what you'll see is that it says we threw an exception for basically the file I/O permission was requested. File I/O permission was not granted to the code, and so the exception was thrown. This is the top-level Windows Forms exception handler, which will pretty print a stack trace for you and tell you exactly where you went awry. And what we can do now is, let's say we've changed our minds. We've said file access is really okay. We're not going to let them write. We're going to let them read. Let's go ahead and change our code inside of the host so that we'll let untrusted code read the volume there. So we'll scroll back up to this method that we had called make execution only perm set. And we're going to uncomment 2 lines. And the line we're uncommenting here grants the file I/O permission. The file I/O permission contains a couple of different bits. You can grant the ability to read files, to write files, to append to files, and basically to discover path information, so to actually tell where a file is located. And in this case, we're giving it the ability to read files and the ability to basically figure out the path. And then just for ease of use here, we've said that you can do anything that's on C:, which is the continuation line there. So you can read and discover paths on C:. We create that, we add it to the permission set, and then it gets applied to the app domain with the execute permission.
So that means you aren't allowing me to do that on a D drive, if I have a D drive, or the A drive, if I've got a floppy drive, or network drives, if I've got network drives.
All correct. Only the place that we've granted.
So let's go ahead and run the application and execute. And now you can see that even though it was able to open the boot any file.
Because we didn't change that code for the button at all.
Right, we haven't changed it. It's still trying to do that. It worked this time because we granted it access to that location on the disk.
And this is really one of the nice things about the security system. We sometimes call it code access or evidence-based security, but it is really flexible. A lot of developers that write code will benefit from this without ever having to write security code. They can basically write their components. They'll know that if they're loaded with full trust, they get to do whatever they want. If they're not loaded with full trust, they run with the appropriate constraint. And for those people that actually need more control over the environment, they can go ahead and build that into their application, decide what's appropriate for their app, and grant permissions accordingly.
Mm-hmm. You can imagine how this would benefit applications like, say, like an email client or something. When you receive an attachment, you could actually execute it. You could identify or specify the policy with which you're willing to let that attachment run, and then execute the attachment with confidence that it's not doing something that would be malicious to your machine, for example. So it actually enables a lot more functional scenarios that we've kind of had to pull back as an industry because of security.
And so, like, for example, right now, if I had an ActiveX control or an executable that came across as an attachment, I mean, either it gets everything or nothing. If I let it run, I let it run, and anything is wanting to do. Where this now allows the application, email program, or the web browser, or whatever the application is that's pulling it across, the Terrarium application, to say, I'm going to allow this thing to have access to this stuff because that's what I'm allowed to do.
That's right, and one of the neat things is that it is fine-grained, so it's not just a matter of saying you're in the sandbox or you're out of the sandbox. You can tweak it to the degree that the degree of trust that you're willing to give to the code, and you can set these fine-grained permissions on it.
You can identify which toys you have allowed in the sandbox.
Right. Exactly.
Yeah. Okay. Now, so this looks like a full-fledged application sample you got. Is this something I can take and let my audience have and put and download?
Sure, you bet.
So now is it clean and ready to download right now?
It's ready to go. Yeah, it's ready to go.
A few episodes back, Mark Bolter was saying he had some code he's going to download, and I don't think he's still yet made that code available for download. So I'll have this code on the show when it goes live.
This actually, the reason it's clean is because it didn't really take much code to write. Most of the like the security checks and the security error dialog that we saw, all of that is built into the system, and so there's really not a ton of code that we had to write to get this ready.
The one really ugly thing that we had to do that's worth calling out is that we had to embed the Microsoft public key in there so that we could trust it. And we ship a utility called secutil, which you can point at a random assembly, and it will spit out the public key of that assembly in a nicely printable form suitable to slam into source code. So we used that instead of actually typing in all those bits. But other than that, it wasn't quite so ugly.
Yeah. That's the kind of thing I think would be really useful for developers, in the sense that you would want to use a lot of these same pieces of code over and over again, and it's the kind of thing that once you have it in your toolbox, it's applicable across all of the applications that you wanted, where you want to control the security permissions in this kind of a manner.
Now, isn't that the sort of thing that should eventually be part of the platform, so you don't have to have this code you're constantly pulling around with you all the time?
Yeah, it's kind of how, I mean, that's how the platform evolves, is we take the things that developers tell us that they're doing the most, repetitive types of pieces of code, and we try and encapsulate those and make it so that they can productively do it with just a one-liner, and so that's a really good candidate for something like that.
Okay.
And of course, a lot of developers using managed code will never write this code. You'll be writing your web application. You won't have to worry about setting permissions and things like that. So it's certainly a subset of folks, but an important one.
Yeah.
Now, another thing that we talked about that was important for a peer-to-peer application to do, in addition to security, is since you've got now data that's going across peer-to-peer, securing that data across the transfer, which means encrypting that data. And you mentioned you had some sample code that showed some cryptography capabilities.
We do. We have a very simple sample that shows how to basically use encryption and decryption. Cryptography is a huge area, and there's a lot of things that you can do. I also want to point out that if you're using the HTTP stack, getting things like SSL are basically for free. You just need to use HTTPS : instead of HTTP : and we go ahead and do all the SSL stuff. So
but that also means you have to have servers that have the SSL certificates and all that sort of stuff.
Certainly.
Yeah.
So a lot of applications that are peer-to-peer kind of apps might want to roll their own crypto support. I would like to caution people that are doing that they really need to take a hard look at it. It's really easy to use the crypto building blocks instead of the frameworks, but getting cryptographic protocols right is a very tricky business, and you need to make sure that you either have someone on your team who really understands it, or that you get an appropriate review from somebody who understands how to do that. What we're doing here, though, is using a symmetric encryption algorithm, and we're going to encrypt a file with a password that's passed on the command line, and then we've got the converse of that, show you how to decrypt it. Let's start by taking a look at the code here. The first thing that we're going to do, let's look at the byte line. Okay, the first thing that we're going to do is take a password that's passed in on the command line, and we're going to use a class called password-derived bytes. And this is basically something that takes an incoming password and transforms it into a strong key. Uses a pseudo-random sequence generator on it to produce a cryptographically strong key out of a good input key. It's deterministic, so if I pass in my same key over and over again, I'll get the same result that I can feed into my cipher again. Those folks that might be familiar with the crypto API, this is crypt-derived bytes. We've wrapped it up and made it easy to use.
So essentially the concept here is I've got a command line application I've written, and I've executed the application and passed it in a password. This application is conceptually going to take that password, encrypt it, pass the encrypted version over to some other client somewhere else perhaps. He's going to decrypt it, get to the data, understand what the password is, and then let me know whether or not I'm authorized. Is that kind of
like what it is? Yeah, what we're doing is taking the password and producing the key. In this sample, we're not actually going to exchange that key with somebody else, but that is what you would do in a P2P app.
Okay.
Yes. Okay, another thing to say about the cryptographic model here is that it's stream-based. What that means is that if you're operating on data coming from a file, data coming from a network, data coming from some random buffer in memory, you can treat it all the same with a consistent model. It's a stream, you read and write from it. So it's really easy to wrap cryptographic transforms around streams. So what we're going to do here is create a file stream, and then we'll create an instance of a symmetric algorithm. So this is the base class for all of our symmetric encryption classes, things like DES, triple DES. What we're using here is the Rindal class, which is the new advanced encryption standard. They all look exactly the same. You can plug them in and out very easily to use different things. We'll then go ahead and set the key and an initialization vector. This is another degree of security input into the algorithm. In this case, we're setting it all to 0, and a lot of real-world apps would generate a random initialization vector as well, kind of as additional nonlinear feedback into the cryptographic algorithm to make it a little harder to break. Then the next thing is what I really want to talk about here. We're creating a new crypto stream, and we're passing that, our file stream, as an argument, and we're creating an encryptor. And then we're actually, the third parameter there is we're setting the mode to read. So what we're saying here is let's wrap a cryptographic transform around this file stream, and then later on we're going to read from the stream, and when we read it, we'll get encrypted data, just as if we'd been working with the original file stream, but after undergoing our transform. Now we're going to wrap one more transform around this because this is very common, and this next one is taking the encrypted stream, stream 1 that we just created, and passing it into a new crypto stream, and this time we're going to give it a base 64 transform. So this will base 64 encode the data. Very easy way to do that. And then all we do is open up the stream that we want to encrypt. We've got the stream that we want to output the ciphertext to. We'll open that for writing. And then we'll just read from the base64 stream. And remember, it's come from raw data through encryption to base64. And then we're going to write it to the output stream. And that's really all that code does. Just read it into a buffer, write it to the output stream until we're done, and then we'll close the file down.
So now, if you hadn't set up all that cryptography stuff ahead of time, this read-write here would just basically read in data and write out the exact same data.
Exactly. And actually, if we wanted to make this work over a network stream or over a memory stream, all we would do is change the kinds of stream that we passed into the crypto stream, and the code would still look the same.
Okay.
So it's a very consistent model for working with different kinds of data. And decrypt actually just looks almost exactly the same. We're going to stagger the order of our transformations because this time we need to take it from base64 to ciphertext and then from ciphertext back to plain text. And so that's really the only difference there. The key setup looks the same. Here we're creating our crypto stream with the from base64 transform. This time we're creating a decryptor instead of an encryptor, and everything else looks the same. We'll open the encrypted stream, open the plain text stream for writing, read from the stream. It goes through the transform from base64 to ciphertext, and then from ciphertext to plain text, and then into the plain text file. There's lots of support for cryptography in the frameworks. We've got symmetric algorithms, we've got asymmetric algorithms, things like RSA. We've got things like signed XML, the XML digital signature standard that's baking. There's things for like hashes, SHA hashes or MD5 hashes, keyed message authentication checks, and really easy to generate random number generators. That came out the right way. So a lot of applications need random numbers. Generating good random numbers is really hard. So we've wrapped a cryptographically secure random number generator inside of the frameworks, and you can use it with just a couple lines of code.
Okay. And is this something we can actually run? Take a look at what it's doing here?
Oh, you actually want to run it? You bet.
Okay, I think it should be built, so run encrypt, and it will give you the command line arguments that we need. And go ahead and type in, yeah.
Let's see.
Better do a dir or something and then echo it to a file so that we don't trash any of our source files there. When we recreate them. I'll just do the arrow. Yeah. There you go. Cool. Great. And then cipher.txt or something, yeah.
Okay, so you've done there, you passed in a password of password, and you encrypted file.txt, which is the directory output, and created cipher.txt as the output.
All right, why don't you go ahead and type file.txt and then...
So there's what it looked like originally. And those two things do look different.
They do look different.
Yeah. And now the concept would be then take cipher.txt and reverse it.
That's right.
To come out the other stuff.
So we'll pass in the same password, we'll give it the ciphertext file, and it will overwrite the clear text file.
And now it comes again.
And we're back where we started, that's right.
And so that's the sort of thing that any peer-to-peer application that's trying to transmit data that could be possibly of a personal nature or something like that, we want to make sure it encrypted that data before it transferred it across the wire so people couldn't get access to it.
Right. Peer-to-peer applications will commonly use what's called a hybrid encryption mode, where you use some kind of asymmetric encryption or key exchange to basically agree on a password. And then you use symmetric encryption, just like we've seen, to secure all the data in the channels. It goes back and forth.
Mm-hmm. Okay. Now we've run out of time. I know that there's some other issues regarding peer-to-peer applications that are useful to think about anyway. One of them is just, from a networking standpoint, how do you actually create the network between the two peer applications? Now, what are some of the concepts you have you think are important for people to understand from that standpoint? Is there something different they want to do, or is it just standard networking communications like they might already be doing?
Well, we have a range of objects that they can use in the framework depending on the need of the application. It starts with something that's similar to a mechanism that the developers are mostly used to, which is just a sockets layer. We have made it a little simpler, but there's basically or easier to use. There's a straightforward way to just create a socket and create a connection and start talking to another peer. There are layers on top of that, kind of following the mantra of the framework, where we've tried to leave the control and give the control to the developer and leave it at a bottom layer, but also layer on top of that with APIs that take care of those steps for you. So I guess the lowest level that's available in terms of talking to another peer is a sockets level, where you could create a connection to another peer and then read and write data between the two peers. Now, as it bubbles up, you might want to, like what we did in the Terrarium, was we built a listener using the sockets layer that actually listens for HTTP requests and processes them and runs inside of the Terrarium. So it's like a little tiny embedded HTTP listener. And we then use higher level classes for sending the data. So the client aspect of it, talking to that listener, you can use a class that we call the web request class. It's in the system.net namespace. You can also go up higher than that. There's remoting infrastructure that allows you to pass messages and execute methods between two peers with nothing more than an API call. And at that point, you're really not even dealing with the network. It's more like executing a method on an object, and the framework takes care of turning that into the right transport and turning it into either a binary or a SOAP representation and sending it across the network.
Mm-hmm. Okay. Now, if someone's already got a networked application that's able to connect to a peer, the stuff we showed them here is fairly straightforward to add to that then. If they don't already have an application that is doing network WinSocket connections, some of the issues they need to be concerned about regarding like firewalls and NATs, that's obviously going to raise some issues for them. What are some of the thoughts you have there, and how do you deal with some of those problems?
Well, some of them are ones
and first of all, what exactly is that problem?
Yeah, the biggest problem with the problem from the application standpoint, the application's perspective with the firewall or with the NAT, is that you can't actually see the peer on the other side of that barrier. So it becomes hard to connect and talk to that peer. And in version 1 of the frameworks, we don't have a lot of infrastructure that actually solves that problem for the developer. So it's something that the developer does need to think about. There are a number of ways that you can get through it. Most of them involve either having the two peers on either end talk to some intermediary that's maybe outside of the firewall or on the other side, that then hooks up the conversation between the two of them or relays the information between the two. It is something that going forward, Microsoft is working on a number of solutions in this space that will make it a lot easier, and we're also relying on some advances in the industry like the IP version 6 protocol that will help us to work through some of these barriers that we have.
So essentially the main solution then is taken, if I've got a peer application that wants to talk to yours, we've got a firewall between us, we need to go to some known location and transfer information there so that I can say, here's my path to get to me directly.
Yeah.
Here's the firewall that sits between us, here's what his IP address is, and here's the information you need to pass to him to allow you to get onto me, and then we can take and actually talk in a peer-to-peer fashion.
Well, usually what you do is you have a known way to get through the firewall. Like you have a known port that your administrator has opened up.
Which is often HTTP or something
right.
like that. Yeah.
And then you use that mechanism to pass the information back and forth between the two peers. So they don't necessarily talk to the firewall directly and say, hey, firewall, can you send this to me? It's more like they have to work through the constraints of the firewall and work with the administrator to set up a policy or maybe open a port on the firewall that the application can then talk through and talk to each other. So you have kind of the barrier of getting through the port, and then you have a different barrier, which is addressing, and how do I actually, once I get through that port, how do I talk to that peer on the other side?
I mean, the firewall is there for a reason. It's there to block data, and so it's just doing its job.
Right.
Yeah. Okay. Now, also from the standpoint of Terrarium, is that an application that from a code standpoint is going to be made available, source code, so people can kind of see how you solve some of your own peer-to-peer solutions?
Yeah, we think that as we've gone through, it's been a great experience working on it, because we have seen a number of problems that we've had to solve in the code that we'd love to be able to pass on to developers. So what we want to do is what we will do initially is take pieces of the terrarium, the pieces that we think are the most useful for developers, kind of like we've done here today with some of these samples, and put them in, just release them as kind of an encapsulated form so the developers can see them and take advantage of them. And ultimately, we'd like to get to the point where we can release the whole thing.
Okay, and that code, when it's available for downloads to look at, will be available through the got.net website or from MSDN?
Yeah, it will be one of those, and most likely got.net.
Okay. Now, for other resources, if there's people in the audience here that want to learn more about writing peer-to-peer level applications, what are some specific resources you think would be very useful for them to go check out?
One of the ones, there are kind of the standard resources having to do with learning about the framework and understanding security and the problem space and the building blocks that are in the framework. And then there are also some specific resources. One of the ones that we use most commonly is on got.net, the got.net site. It's got.net.com/team/P2P.
Okay, and that you can get a lot of resources from other people and actually trade information with other peers in the industry.
Right.
In writing peer-to-peer applications.
That's right.
Okay. Well, thanks, Lance. Thanks, Erik.
Thank you.
Thank you.
And so hopefully that gave you some information about how peer-to-peer applications might be able to solve some of the problems you have, how to take and include some security and encryption capabilities in an application to make it a robust, secure application that your users can use and feel confident using that, as well as understanding a little bit more about the .NET framework and the Terrarium application, which I'll include more links in the transcript so you can find more information about peer-to-peer, Terrarium, and the .NET framework. Thanks.
Many people at Microsoft have been actively preparing for the launch of Visual Studio.NET. And with me today is George Bullock. He is a .NET Strategy PM with the MSDN Group. George, welcome.
Thank you.
So tell me about what you've been doing to prepare for the .NET launch, Visual Studio.NET launch, and what your role in MSDN in general.
My role in MSDN in general is to ensure that we're getting content out to developers that helps them understand and develop with .NET. And to support the Visual Studio.NET launch, we've been working probably for the last 2 or 3 months to make sure that we're working with groups around the company to get the content that our developers will need to understand this important new product.
What type of content are you focusing on trying to acquire?
We're focusing on everything from overview content that lets people understand the technologies and how they fit together, all the way down into how-to content that lets them do their job on a daily basis.
So what have been some of the challenging things you've been working on with the launch? I imagine you're working with product groups and marketing groups and developers and all kinds of people.
Yes, and I'd say the most challenging and fun thing has been bringing marketing, product UE, which is product documentation, bringing all these people together and getting them all on board with ideas for what our developers need and what our customers are looking for to make them successful. And it's been really fun. It's been sort of a pilot project for bringing people together in this way.
And how long have you been with the MSDN Group?
I've been with MSDN for 2 years, which is how long I've been at Microsoft.
Okay, and what did you do before Microsoft?
Before Microsoft, for the 3 years before I came here, I was a developer and architect with a small firm in Los Angeles, and we did enterprise development for internal applications using COM, ADO, MTS, and Visual Basic 6.
So was it hard to make the jump from moving from LA to Seattle?
It was. The first year was tough. The second year, now when I go back to LA, I really am glad when I touch down back in Seattle. It's now hard to go back to LA.
Really?
Yeah.
So have you always been working in the technical industry?
No, I've been in the technical industry for about the last 10 years. Before that, I was in the music industry.
Oh, really? What did you do?
Well, in the 80s, I performed in a variety of bands, most of them original rock and roll, and also some jazz bands. And that was really fun, but it's a tough life. And given I had played with technology most of my life, so given my proclivity for that, I decided that's a better way to make a living and have fun at the same time.
What was tough about being in the music world?
Eating noodles constantly. No, I mean, seriously, it's a tough industry, and, I had very little money, my car door tied shut with a rope and that kind of thing. So, now here I am working at Microsoft.
Right.
So anything can happen in this world.
So what instruments do you play?
I play largely guitar. I also play piano, bass, and drums, but guitar is my main instrument.
So do you still get to play today?
Yes, and actually, the interesting thing about coming to Microsoft and moving to Seattle is more than ever, my music career is satisfying and a great part of having a balanced life. So I found a number of people here at Microsoft who I'm playing with, and we have a jazz trio, and we play a lot in the Microsoft circuit, if you will, which is Christmas parties or other events that admins put together for VPs and other groups around Microsoft. And it's really a fun way to play, make a little extra money. We also get around the city and play in a lot of the jazz clubs.
So there's a lot of opportunities in Microsoft to not only do your job, but work on and meet people who share your hobby interests.
Yes, traditionally music and computing, and then even before computing, music and things like cryptography were fields that had a lot of synergy. So for example, in World War II, Juilliard and other music schools were scoured so people could find cryptographers who could help with the efforts in World War II, and that's continued on into the computer industry. So it's amazing when you get into the computer industry, especially at a place like Microsoft with so many interesting and smart people, how many of them have some involvement with music. It's really cool.
Mm-hmm. So what other things do you like to do outside of work?
Well, I like to play music, of course. I love my little daughter, Annie, and so I spend a lot of time with her.
How old is she?
She's 18 months.
Oh, great.
And let's see, my current bragging point is she says chess, moves, and queen. So she's close.
She's going to be a chess player.
She's still having a tough time with the Rui Lopez exchange opening, but you know, it's just a matter of practice. But seriously, having her is a joy. She's a bright and energetic young girl with a great sense of humor, and so it's just fun hanging around with her. And other than that, I love to read either technology or history.
So what are you most excited about with the launch? Are you going to be down there at VS Live?
Yes, I'm looking to get down there and work at the .NET Framework booth with some of my friends in the who are what we call tech champs for the .NET technologies, and that's going to be a great opportunity. So what am I most excited about the launch? I think we've put together a great package of content, and obviously I believe, as everybody here at Microsoft does, that we have a fantastic technology platform for developing new types of applications going forward. So I'm really excited about having played a part at MSDN to help put together this great content package we have. We're looking at a 6-week window with launch as the center point, where we're just going to put out great content that our developers are going to need to get started and get up to speed with this stuff.
So hopefully some of our viewers will be down there and they can see you in the booth.
Absolutely. Love to talk to you.
Well, that's great. Well, George, thanks for your time today.
It's been a pleasure. Thanks a lot.
And that brings us to the end of another episode of the .NET Show.
And stay tuned for the next episode where we talk about debugging in Visual Studio.NET.
And until then, we'll see you on the web.